Okay, boss. In the last class, we've seen what is HANA. Just it's like a normal database. Only thing is, it is an in-memory database where it does store and process your data in main memory. And then it's a platform because it comes along with the certain hardware capabilities. Appliance and the platform is like it has got its own access engine or application server where you can deploy your own applications. Now we're trying to focus on what makes HANA so fast. Like it's giving you high performance, right? Now why is it so fast? That's what we're trying to focus on. Okay, there are certain hardware capabilities and there are certain innovations from software which is making it fast. There are certain improvements which is being done towards the hardware capabilities, and there are certain innovations towards software which is making it so fast. Out of this, first one is your multi-core architecture, multi-core parallel processing, and then about storing your data in main memory. From the hardware perspective, there will be two things which is really affecting the performance. One is the multi-core massive parallel processing, and one is about storing data in your main memory. And from the software perspective, this is the key, very, very important, row and columnar storage. So, like normal databases allow you they store data in form of a row store table. But in HANA, you have flexibility of storing that as a row store or column store. And enabling us to store data in a column store is actually improving the performance of your querying it. And then the concept of compression coming in, improving the performance, and then also partitioning this. And then there's some concept called no aggregation tables. Generally in BW, you build aggregates on a cube if it is BW, or if it is BO, what they do is if it is non-SAP, they will have summary tables. They'll also have detailed tables, and they use aggregate awareness function and to decide whether the data should be referred from summary table or the detailed tables. So generally you go about having a detailed level of tables and also summary level tables to improve the performance of the queries. But in HANA, because of the columnar storage, you don't have to really worry about maintaining aggregated data. You can just leave the data denormalized. System will take care about the performance here. We'll see that one by one. Now, so when you say it is multi-core, what is it? Okay. See, now if you look at a computer or if you look at a CPU, it'll have a processor, you'll have motherboard, and top motherboard you'll have processor, right? You heard about saying dual core, quad core. When you say dual core is what? You have a processor with 2 cores in it. When you say quad core, you have a processor with 4 cores in it. And core is actually that part of the processor which actually does your activities. When you look at the performance of a CPU, it shows core wise. Means like core is the one which actually does your work. So when I say I have a quad core processor, it means I can have 4 operations can be done at a point of time. Okay. So hardware has been improved to a level where I can have a CPU with 12 cores in it. I can have a processor, one chip, okay, one processor chip with 12 cores in it. And and one motherboard can have up to 8 processors in it. Imagine a motherboard with 8 processors in it, and each processor having 12 cores in it. And 12 into 8, totally it comes up to 96 cores. And if you want to really enhance this, you can also go about, say what you can do. You can have distributed systems, right? You can have 4 systems together acting as one HANA server also. If you want to really have massive processing, then if I have 4 motherboards or 4 CPUs together acting as one server, then it will be 96 into 4 is the number of cores. And more number of cores we have, the more the performance is. Okay, boss. So yes, your motherboard will have the CPU or the processor, and processor in turn will have cores in it. And it's been improved such a way that now each processor is able to have up to 12 cores in it. And one motherboard can hold up to 8 processors, and each processor can hold 12 cores. So in one big motherboard, maximum you can have up to 96 cores. And if I want to really expand this out, I can have distributed system where 4 systems together will act as an HANA server. You'll have 4 motherboards, each motherboard having 8 CPUs, 8 processors, and each processor having 12 cores. It will become 96 into 4 is the number of cores of available to us. And so many operations can be done at a point of time. Okay. So it's not about just having multiple cores, and leveraging it. Those cores is also important. Massive parallel processing. So now what is this parallel processing? Now look at this. Let's say I have a table with 3 columns. Column A, column B, and column C. And I'm executing a select statement saying select A, select B, select C from a table. Okay. So when I execute this query, internally what happens? There will be multi-cores which will be processing this query, not one core. So how can that be done? If you look at vertical fragmentation, you can look at this. I'll have core 1 which will be processing reading data of column A. I'll have core 2 which is reading data for column B. And if column C has got lot of distinct values, further it will be divided into multiple parts, and one part of column C will be read by core 3 and other part of column C will be read by core 4. So 4 cores are involved in reading the data for my select statement of reading 3 columns and giving me the results. So obviously when you have 1 core doing your operation and when 4 cores are doing your operation, obviously you should see difference in the performance. This is what we refer to as multi-core massive parallel processing. You got many cores, and where they have been deployed, they have been enabled to work parallelly. That is called as massive parallel processing. And because of this, HANA is giving you high performance in the results when you run your queries against it. Okay, yeah.
Question, sir.
Hello?
Hello?
Yeah.
Yeah, I have one question, sir.
Yeah.
Here you said we have 3 columns in a table.
Yeah.
And each allocated to a core 1, different cores.
Yeah, yeah, yeah.
Will that HANA takes care of by inbuilt, or the one who creates the table has to be allocated to the each core?
No. It's all, mute yourself please. It's all inbuilt technology. When you're writing a select statement, you don't say select column A using core 1, select column B using, you don't do all those. You just write a normal select, say select column A, column B, column C from table. This is all inbuilt technology which system takes care of doing it. But there's one option, while writing your select, you can control whether it has to execute parallelly or sequentially. You can control that option. Whether it is parallel or sequentially, whether it does leverage multi-core, it's all built-in technology in HANA server. It's not you do it. Okay? It's all done by the system. Yeah.
Okay, thank you.
Yeah. And next next is the RAM bus. Now what they say is previously we used to store data in disk. Now when it comes to HANA, we're going to store data in main memory bus. Very, very important. If when you look at HANA server, it will be mainly having 3 storages. Okay, one is, you can say, main memory. We call it the data volume and log volume. Main memory, data volume, and log volume. So when you look at HANA server, it actually stores your data in 3 different storages. One is your main memory, one is your data volume, and one is your log volumes. Okay. And your data volume and log volume are normal disk. Data volume and log volume is your disk, and your main memory would be your RAM. Okay, this is your main memory, which will be RAM, and your log volume and data volume both are your disks. Okay. Okay, boss. Now what I mean to say is, now we're saying HANA is an in-memory database. It does store data in main memory and process data in main memory bus. But that doesn't mean it does store all data in main memory bus. No. It does not store all the data in the main memory bus. No. So now we say it this way. So technically you can understand it something like this. Every write is to the RAM, okay? It writes it to the RAM. Sorry. Read. Every read is from RAM, you can say, and every write is from the disk to the disks. Every time you insert data into the table, it will write that back to the disk. But every time you read, it reads from the main memory. I'll tell you. So technically in the backend, this is what happens. Every write operation you do, it actually writes back to the disk. And every time you do reading, it actually reads from the main memory. So now how does it happen? Now imagine, let's say we have only one table, okay, with let's say some 0 records. There is no data in it at all, okay. Now we have switched on the server. The server was down. There's only one table. Now we have switched on the server, okay. Now as soon as you switch on the server, what happens? It will load all the system tables. Because in HANA, you're going to create a lot of tables, you're going to create a lot of views. So there should be some system repository tables. Like say in BW you have RS star tables. Any application you take, that will obviously need some tables to store all the metadata for you. A tables, A views, then information standard tables. All those is referred as system tables, which will be row store tables. I'll tell you what is row store column store, but that will be normal row store tables. So when you switch on the server, it actually loads all the row store tables into main memory bus. All row store comes into this by default, which is nothing but all your system tables which have been configured as row store tables will be loaded into main memory as soon as you switch on the server bus by default. Okay. Now we'll discuss on why, what, we'll see that. First it loads all the system tables into the main memory bus. But none of the column tables are loaded into main memory. My T1, which is my application table, which I have created, like say employee table or department table, some table, sales order table, the table which has been defined to configure my application, it's like T1. And that is a column store table. None of the column stores are loaded into main memory at all. When you start the server. But suppose I have a requirement saying this table is really critical. Every time I switch on the server, this table has to be loaded into main memory. In that case, we use a concept, we'll see that later, we use a concept called preload flag. So what we do, we'll configure this, we'll control this table property. There will be a table with property called preload. We'll enable this property called preload flag. Now when you enable that, what happens? Every time I switch on the server, all the system tables comes into main memory. It also loads the column store application tables also into main memory, for which the preload flag has been enabled. Column store table preload flag enabled our tables would assign along with the system tables. But imagine I've enabled the preload flag for this also. So now what will have? You'll have T1 with how many records here? 0 records. Okay, boss. Now let's say what you've done. You're just using some insert statement. Let's say you execute one say insert into this table so and so values, and you inserted one record. And thus this record will be returned to which one? To the main memory. Saying so you'll get one record in the main memory. And in the log volume, it maintains a log saying record 1 was been inserted. It maintains a log saying there's one record was inserted in the log volume. Okay. Again, you do another. Let's say you inserted one more record. So number of records in this table will be what? 2, and it maintains again a log in this log volume saying record 2 has been inserted. Okay, boss. But the disk it is still 0. I just have those 2 records in where? In main memory, right? So then what they do is in the server configuration there will be a property called save point. In the server configurations there will be a configuration point as save point. They configure it as for every 5 minutes or every 10 minutes depending on the server requirements. Now when I say my save point has been configured as 5 minutes, for every 5 minutes my system will write back the data from the main memory to the disk. Now disk will get what? 2 records. Let's say we have started the server at 11 o'clock and then from 11 to 11.5 we have created 2 records in the table, and at 11.5 the save point was executed, and these 2 records in the main memory was been written back to the disk. So ultimately what is happening when you when you're writing, ultimately the data is written to what? Disks. And when you're reading, it actually reads from the main memory, I'll tell you. Now the table is in the main memory, right? So it reads from the main memory. Okay. And let's say, okay, you'll have a concept it's called load and unload bus. Let's say what I've done is, after 11.5, I didn't want this table to occupy my space in the main memory. I've unloaded it. Unload means what? The memory it is dropped from the main memory, but the table is still in the what? In the disk. Now let's say now I'm running a query saying now 11.5. Now it's been we're looking at time after 11.5. I'm running a query saying select so and so columns from table 1. Table as T1. Yeah. So does it find the data in the main memory bus? No. It goes to the so when there's no table loaded into main memory, during first fetch on the table, it loads the table into main memory and then gives you. And then gives you the results. If you run the same query second time, it obviously finds the data in what? Main memory. It's more or less like acting like a cache. If you have not loaded the table into main memory during first select or during first fetch on the table, it will load the table into main memory and then it gives it to you. If the table is already loaded, it just takes from main memory and gives it to you. Clear on this? Okay. Then even when it comes to loading of data into main memory, you'll have something called full load, partial load. Say for example, if I say select star from this, I'm trying to read all the columns of the table, then that will be referred as full load. Means all entire table content is loaded to the main memory. But for example, let's say my table has got 100 columns, but my query says select column 1, column 10, column 11, column 20 from the table. Then it does load the data table into main memory, but only with those 4 columns are filled. We call that as partial loading. So when you run the query, during first fetch, it does do only partial loading only. Let's say your query was fetching only 4 columns. The data of those 4 columns is only loaded to main memory, not the entire thing. Clear this? Okay. Now let's say now the time was 11.5. Okay. Now let's say the time is 11.5. But the problem here is, now let's say you insert one more record after this. Let's say now this becomes what? 3. This was old logs. Now it'll say this is a new log. What is record number? 3. And it'll say what? Let's say I insert one more record number 4. So how many records here? 4. So when will be my next save point? 11.10. So by 11.9, I have created 2 more records into the table bus. Right? Let's say exactly at 11.9, there is a power down or server was shut down. Now can I say the RAM main memory is volatile? Yes or no? Yes. So the data in this main memory will be deleted, gone. All the data what I got in main memory is gone. So now the time is at 11.9, we've lost power, but all the data we had save point executed at 11.5. So we have 2 records in this data volume, which is the disk. And there are 2 more records inserted during like 11.7 and 11.8, and at 11.9 we lost the power before the save point. And RAM being volatile, we have lost the data. Right? So when the power is down, again when you get power, again you switch on the server back. Yes. So again what it does, it load all the, what? All system tables. Okay. And if this it will also load the columns or tables if you have enabled what? Preload flag. Let's say it loads this table T1 with how many records will get? T2. Okay. And it will re-execute those logs what is there in the log volume. In the log volume, it will have the log with the entire statement what has been executed. And it re-execute those logs again and it brings it up what? With 4 records. What was the statement was executed in a transaction logs are. So when it reloads this table again, when you switch on the server, it re-execute those logs again to bring the data back to the state what it was when you lose the power, when you lost the power. Got this point? So that's how it is able to handle the non-volatile nature of main memory. That's why every write will be to the disk ultimately, and every read would be from main memory. This is how it handles it internally. Clear on this now?
Sir, one question.
One second. And this is what they call it data persistency. Means actually when you look at a data, see, HANA is a database, right? Any database must satisfy property called ACID. Atomicity, then they say durability. All that. Durability means if once I have the data into my database, it must be there forever until I delete it. So that is what we call it as data persistency. So when my HANA is an in-memory database, how is it guaranteeing me the data persistency? This is the mechanism. Got this point? And one more point to be understood. Let's say your RAM is of 128 GB RAM bus. Let's say your RAM size is 128 GB. You've been running a lot of queries. Definitely there will be some point of time where the RAM gets filled. Definitely there will be some point of time the RAM gets filled. Then again let's assume now RAM is completely filled. Now you're trying to run one more query, which is not there. You're reading from a table which is not there in the main memory. It has to read from where? From the disk. When it is reading from the disk, it has stored that copy again into my main memory bus, but there's no space, right? Yes or no? Then then it has to unload some tables. Unload means it has to remove some tables. So during that point of time, I can't go manually and say unload this table A, B, C. I can't do that, right? So what you do is, for every table you've been having in main memory, you control a property called unload priorities. You will maintain some number from 0 to 9. For every table, you control a property called unload priorities. Okay. So the priority ranges from 0 to 9. The higher the number it is, it has to be unloaded quickly. More earlier unload. And more the number is, and as the number is less, it will be unloaded later. So let's say now the RAM is completely filled. You're trying to run a new query, and then it has to read a table, another table, and then when it is putting in, what it does, it finds a table which has got highest unload priority will be unloaded first. First, all the tables with unload priority 9 will be unloaded. Next, all the tables with unload priority as 8 will be unloaded. Next will be 7. Next is 6. It unloads those tables and makes a space around it and then puts the data into this. You getting this? So by using this unload priority, system will be unloading the tables automatically. So generally what you do is you identify which tables are critical for you. For those, the unload priority will be less, so that they will be unloaded later point of time when it is really critical. But the tables which you're not really using a lot, the unload priority would be higher, so that they get unloaded quickly. So we can control these properties of preload flag, unload priority, whether loading or whether it has to be loaded or unloaded. This will be normal manipulation operation where you load the data into main memory and unload it from main memory. But if you want all this to be happen automatically, we call that as we control this property. While defining table itself, we can enable that for preload, and we can enable that as set up the unload priority. This will be manipulation. You actually manipulate whether it has to be loaded or unloaded. This will be the properties on a table set up for whether when you switch on the server, this table must be loaded to main memory or not. That is for what? Preload flag. And once the RAM is completely filled, if it has to create some space in the RAM, which table should be unloaded is defined by what? The unload priority. This is again a property of a table. Okay, boss. See, this is how the HANA handles about storing data in main memory. Okay. The concept, what we mean to say is, in most of the other databases, they store data in the disks. Okay. So whenever they have to process some query from the disk, they bring it to main memory, and processor will read data from main memory and process it and give. There will be some amount of data where it takes it, registers all those, and then process and gives it out. Now what they say is, it is one, and then when it comes to HANA, it does read data from where? From the main memory, not from the disks. They say the time, when you compare the timelines when you're reading from the main memory and when you're reading from the disk, it is 1 million times faster. Not percent, 1 million times it is faster when you get to read it from the main memory. So if I have a query or a database, let's say I'm executing some query on a database which is supposed to read from the disk. If I'm supposed to run a query on a database which is reading from the main memory, you will see difference in 1 million times. That's the point. And previously we never had a RAM size too much where we could store data in it. Because of the hardware advancement, now we are able to have the RAM with up to 2 TB also, 4 TB also. So now we have the flexibility of storing data in main memory. So what the concept is, instead of storing in the disk, which is really slow when compared to having data stored in main memory, why don't we go with main memory? So that's where in-memory concept has come in, and they wanted to store in main memory and improve the performance of data processing. And the question was, when you decide about storing in main memory, the question comes is, if it is volatile, then when you lose power, you're going to lose data. Then how is it going to handle the data persistence? That's how it comes. So now understand, HANA is an in-memory database. Since it is going to process the data from main memory, it is giving you high performance. And if the question comes saying, if RAM is volatile, then how does it handle the data persistency or data durability? You understand about save point and then data volume, log volume, and loading, unloading, preload and unload point. This is how it handles the data persistency in the backend or durability. So once I insert data into it, it guarantees me 100% fail lowercase. Next, you can still think next level saying, okay, if the data in the disk is lost, that will be a question for any database, because every database would store in the disk. That is a question of anything. So then you'll have concept of backup. So this, you'll have a backup of this data volume regularly, and even for log volume you'll have backup. And suppose, okay, so if there's some problem with the log volume, what from the backup what you have taken, you will reload those logs and execute those logs. They'll be taking log volume backup every day or every 1 hour depending on their requirement. Suppose if there's some problem with the logs, they can restore the logs from the backup again and re-execute those logs again. It's all out. Okay. That is what they call backup and disaster recovery. Suppose if they lose even this data volume or log volume, since they have regular backups taken, they can restore those backups and re-execute those logs again and get the data to what state to what it was. This question will be for any database, not only for HANA, because every general database also would store data in database. They need to have normal backup flexibility, and then they need to have flexibility of restoring it also. Getting this? So then the concept of backup and recovery comes in.
Does it take full table from data hard disk to memory? Like example,
that's what I'm saying. Suppose if you, let's say the table is in the disk, is the question what is asking me is, does it take the entire table into main memory? So answer to that is, say I've got a table with 100 columns in it, okay, and you're trying to fire a query saying select column 1, column 2, column 3, and the table is not in the main memory. What did I say? During first fetch, it has to load into what? Into main memory. So now there are two concepts now. Is it a full load or partial load? Since you're reading only 3 columns, it does do only what? It does loads only column 1, column 2, column 3 only into main memory. That is called partial loading. At that time, the entire table is loaded. Entire table is loaded. He's saying not about doing fetch. Suppose my table is flagged as preload, entire table is loaded into main memory. It is by default full load.
Then it will be like by mistake someone did any the wrong thing, like a PB data, data and all.
Everyone will not be giving everyone will not be authorized to change the properties of a table. Generally, it will be more of an admin person who takes care of it. And they'll write. Other day, there was a person who previous batch student. He called me. He was working on this. His problem is the RAM is getting full. He called me saying the RAM is completely getting full. What should I do? Then I said, set up this unload priority for the tables. Then he says there are a lot of tables. How should I set? Then I gave him options like you set one by one, or one option is you'll have there will be backend table called tables. In HANA, in the system schema, you'll have a table called tables which will hold the properties of every table in it. Okay. So perform an update statement on the table which actually updates the priority flag. So when you're trying to update a system table, everyone will not have the authorizations for it. So then what is done is, he has identified the list of tables, then he is execute saying update this table, set unload priority as 9, where my table name is equal to table 1, table 2. He has execute this, which is updating the system table in the backend. Okay. Okay, boss. So that
I
is
have one question
yeah,
here.
please. Yeah.
Hello.
Yeah, please.
When you say RAM is volatile
Yeah.
and when power gone, so
Yeah.
all the data which is stored in main memory is lost.
Is lost. Yes.
Yeah. So when we switch on again the server,
Yeah.
you said that it will take the data from the disk and log
Yeah.
when we execute the query.
Actually, log will not have the data. Log will
Yeah.
only have,
So my
it's like an audit log, which will have the what transactions, what events were performed on the table.
yeah, but how system knows that these logs should be executed automatically? Is that any
No.
pre-mechanism that
It's
we
all
had built?
built-in system programming. When you restart the server, it takes the data from this disk volume to main memory, and then it re-executes those logs what is been maintained in the log volumes. It's all built in the system. So since I made you open so much, you are getting those questions. I should not speak. I should say we basically execute those logs and correct it. That's what I should say. But for you to understand, I'm just writing like record 3, record 4, all this so that I went in detail. Now you're getting doubt. What is the logic of finding it? That is not your way. That's all the system programming, which is built with C or C++, which takes care of it. It's not your job. We're just trying to understand the mechanism of the system, how it does. Okay. So we are not really worried about the logic or the program which does it. We are only worried on how is it handling that. That's it. We are not worried on the coding in the backend. That is in the software. That is what HANA software does. Okay. And someone is asking about power failure. See, simple. Let's say now the time is 11, and I have a table with 0 records now. Okay. And let's say this table is loaded into main memory bus. I insert some 2 records. At 11.5 there is a save point. What happens? The 2 records will be returned to what? Disk. Let's say after 11.5 till 11.8 I have created 2 more records. Now the table in the main memory has got 4 records and the table in the disk has got 2 records. And then before, actually next save point is supposed to be at 11.10, but I lost power at 11.9. So at 11.9 what is the situation? That these records are gone, but the logs are still there and I have the table. Now when I switch on the server again, this table is again loaded to what? Main memory with 2 records. It executes what are the logs which are captured in the log volume are re-executed again, and then it brings this table status back to what? 4. That's the power failure case. ఈ టేబుల్ కి లాగ్స్ ఇవేనా, ఎప్పుడు ఈ లాగ్స్ అవన్నీ నాకు చూసుకుంటుంది, మనకు సంబంధం లేదు. దట్ ఈస్ ఆల్ సిస్టమ్ ప్రోగ్రామింగ్ విత్ సి ప్లస్ ఆల్సో సిస్టమ్ టేక్స్ కేర్ ఆఫ్ ఆల్ దిస్. Not record, log. Log volume will only maintain the log saying there is one record inserted on this table with these values at this time. It's like more like an normally even applications you build this kind of audit log saying who created this record, what was the statement of execution, and you also collect some comments why is doing all this. Something like that, it collects that audit log. Okay. Okay. So that was from that. Hello?
Hello.
Yeah.
I have a question.
Yeah.
Yeah, can you show the previous picture once?
Yeah.
You see, like once the save point will be executed, will the records in the log volume get cleared? This record 3rd and 4th, once the save point is executed,
Yeah.
will it get cleared?
Yeah, generally they'll clear it because what they do is, suppose if your RAM is let's say 128 or let's say 100 GB. Okay. Now generally the disk would be 400 GB, 4 times of it, and generally the log volume will be 1 time 100 GB plus. Suppose if I don't clean this, the size of it is occupied, so there will be no more logs captured. So what I do is, when I say backup, I take this record one inserts as a backup and keep the logs and clear this out. And the backup this would be test. I keep clearing it so that there will be a space for the new logs coming. If I don't do that, at some point of time the log volume is filled and there can be no more logs being captured into it. And when you want to restore the system again, then I can get this data logs restored into log volume and then restart the server which will execute those logs again back. That is like restoring data to a particular status of state what it was during that date. Because if I have logs at each day level backup, let's say now it is 21st, okay. So we have captured logs at 18, 19, 20. Now you want to get back, so there was something happened on 20th and 21st. You want to get back to the database at what it was at on 19th. Then what you'll do, you'll take the log still 19th and re-execute those logs. That also can be done. You'll see you may have taken backup on, let's say on 10th. I get the backup of this database from, restore the backup of 10th into it, and then re-execute those logs from 10 to 19th. So then the database status will be as it is, as if it is on what? 19th. You can always restore to any point of state. That's what flexibility. Yeah?
Okay, thank you.
Yeah. So that's where the concepts of backup and restore comes into picture.
Backup is done automatically or a certain period of time we need to do backup?
Generally, in the real time, they'll schedule that as a job. The process, that will be like a job which will be collecting the backup regularly. Backup generally database will backup అంటే దానికి ఒక ఫైల్ ఉంటుంది .db అని ఎక్స్పోర్ట్ చేసి అది కంప్రెస్ చేసి పెట్టుకుంటారు.
ఇన్ కేస్ ఆ షెడ్యూల్ చేసే టైం లోపే పవర్ ఫెయిలియర్ అయింది అనుకోండి, ఇన్ కేస్ బ్యాకప్ అవ్వలేదు కొన్ని డేటా సంథింగ్.
Yeah, backup. See, now his question is ఇంకా ఎక్స్ట్రీమ్ అడుగుతాడు. క్వశ్చన్ ఏంది, at 11:09 there was a user who is trying to insert one record. And he is trying to insert one record. He just executed insert all this. There's a record commit, but he is not still executed commit. The commit got. So then he lost power. He was in the middle of process. He was in the middle process of creating a new record, and there's a power. Then what will happen? That's what he's saying. Okay. So actually, what happens? You'll have something called transaction manager. And I said every database should satisfy the property called ACID atomicity. A means atomicity means what? If either the transaction should be completely done or completely undone. Suppose if there's a break in between, it will not allow you to perform the transaction at all completely. Complete transaction is undone. For example, you're taking amount from account 1 and depositing to account 2. So as soon as you take the amount from account 1, you lost power. Then what? The amount malla adve tanaku vettestunnaru. Either transaction is completely done or transaction is not undone completely. So you'll have something called some component called transaction manager, which actually takes care about this atomicity. Whether either transaction is completely done, if it is stopped in the middle, it will be rolling back to the status what it was before that. జరిపితే మొత్తం ట్రాన్సాక్షన్ జరుగుతుంది, లేదంటే ఇంకా అసలుకి జరుపుతుంది అన్నట్టు. అలా ఓకేనా? Okay, that was from the hardware. Then it is software innovations, row store and column store. Very అంటే హార్డ్వేర్ నువ్వు చేసేది ఏం లేదు, సిస్టమ్ చేసుకుంటాడు. నువ్వు కొత్త గొప్ప చేయగలిగింది ఇది ఒకటి. రో స్టోర్ అండ్ కాలమ్ స్టోర్. See, majorly from hardware, it's all system programming which takes care of it. And this is where it depends on you. As a modeler, you are the one who decides whether you have to create a row store table or a column store table. Let's say you're building a warehouse with SAP HANA. Okay. Now, you got to extract data from different systems and store data into physical tables of HANA. Let's say I'm extracting sales order data from ECC or non-SAP system and putting into HANA database. Now I should decide, I need to have some table. If any database, ultimately, if you want to store data, we use what? Tables. Now, when I need to store the sales order data into this table, I need to decide whether will I create it as a row store table or a columnar storage table. HANA will support two types of tables, row store and columnar storage. Now, as a developer, as an architect, you should be in a position to decide to store this sales order data, will I go for row store or will I go for column store? So it is in your hands. This is not system does not decide this. You will have the flexibility of deciding whether this table should be a row store table or should this table be a column store table. Fine. So it is very important you understand the benefits of what benefits do you get from row store, in what benefits do you get from column store. Then you will be in a position to decide, okay, I would like to go for column store or I would like to go for row store. Very important. Okay. Simple. Look at this. Any database, whether it is SQL Server, Access, or DB2, DB6, Sybase, any database, ultimately they store data in form of table. So there will be only one data persistency object. Any database you refer, if you have to store data physically, persistently, you have to use a structure called table. And then a database ultimately table create then a database, right? So table looks something like this for you. Let's say you see a table like this with country, product, and sales. So I've got country like India, Germany, US, and I've got some products, chocolate ice cream, chocolate noodles, and some sales. This is my table. Yeah. So you see the user interface might be different, but most of the database will show you table like this. When I say select columns, all this show me table output, it will show like a grid. Database very good, but UI different. Ultimately, they show you a table something like this, right? With like rows and columns with multiple cell matrix like this, right? But do you think even in the backend it is stored like a table only? Let's say any database ultimately, if you want to store data persistently or physically, permanently, you always use tables, right? You create some table which will have some columns and you insert some data which will formulate rows. And whenever I say show me this table, your database application or database software will show you a table something like this. Yes or no? This is how screen marthanadu ultimately it will table. So when it shows a table like this, does it store a table like matrix also internally? Even in the backend, does it store like a matrix? No. When you try to see, they have built an UI which will enable you to see like a format with rows and columns. But internally, it does not store like that, right? It will store it in a different mechanism. And then at runtime, when you want to see data, it does convert those mechanism into a human readable format, then gives you in this format. Yes or no? So now knowing that, now look at this. So now if this is a table, you know what is column, right? Country is one column. This vertically you refer it as what? Column. Country, table, product and what? Sales. So when any database, ultimately you have to store data in form of a table. And when you say define a table, it is a set of rows and columns. So these are my columns here. Country is one column, product is one column, sales is one column. Now what is a row? Each record in a table is a row. Each record in a table is a row for you. Now say I've got 4 rows indicating how many records? 4 records. Each row will represent one record. So now you understand what is a row? Row and this is one row 1 and this is row 2 and this is row 3 and this is row 4. Okay. And this is column 1, this is column 2 and this is column 2. Now you understand what is a column, what is a row of a table. Okay. Now see, in HANA database, either you create a row store table or either you create a column store table. The way you see the table is all one and the same. When I try to see the table output, you will obviously see columns and rows. You see it as a table structure only. Either it is row store or column store, ultimately you get to see it in the same way only. But the internal mechanism of storing the data would be different. So in HANA, if I create a table saying row store table, but internally the mechanism of storing a row store table is different. Internally the mechanism of storing a column store table data is different. But for ultimately when I say show me table, it shows me one and the same. You don't see any difference in the output. Whether it is row store or column store, you don't see any output difference. But internal mechanism of storing the data is different. Okay, boss? Now look at this. So now if I create this same table, say I'll say create table with so and so columns as row store and you'll have some syntax where you say I want to create column table and it creates a column table. If I say create row table and it creates a row table, that's it. It's only extra keyword you specify in the create table statement, which enables it to create whether row store or column store. Okay. Assume I'm trying to create a table with 3 columns: country, product, sales as a row store tables. Okay. So if I create that as row store table, in what mechanism does it store the data in the back end of the systems, in the back end disk or whatever it is? Yeah. Now look at this. So if I created that as row store, each row is stored in one continuous memory location. See, if it is main memory, it will have page by page, right? Memory is organized by pages, 15-bit page or 8-bit page, or depends on that size. So I've got one row, right? India, chocolates, 1000. All these three, the entire row will be stored in at one memory location. It takes row 1, finds the memory location which is free, inserts in that, and then takes row 2, finds next memory location which is free, inserts row 2, same way row 3, row 4. The data of each row, each record is clubbed together and stored as one set, data set at one memory location. If I go at every memory location, I find the complete record. That is row store. Okay, boss? And if I create the same table as column store, values of one column are stored in one continuous memory locations. It takes all the values of country and puts into one memory location. It takes all the values of product, puts into one memory location. It takes all the values of sales and puts into one memory location. RAM. Okay, memory RAM will have different memories like pages. It finds a page which is free and inserts the data into that page, particular page. So when I say row store, each record is stored in one continuous memory locations. And when I say column store, all the values of one column is stored in one continuous memory location. So all the values of column country are stored in one memory location. All the values of column product are stored in one memory location. All the values of column sales are stored in one memory location. Okay, boss. Now I know immediately you start getting doubt if the columns are stored separately. How do I know? This value India belongs to chocolates and chocolates linked up to 1000. Correct? Question doubt వచ్చిందా? Right? Tells. So when you store data in a column store table, all the values of one column are stored in one continuous memory locations. Now you don't have linking which value is linked to what. Okay, so for that what it does is it maintains something called positioning indexing. It would have something called positioning. I'll show you with the numbers how does it move, but there will be something called positioning indexing, which tells you row number 1 of this column is linked up to row number 2 of a second column and linked up to row number 3 of a third column. అంటే ఇక్కడ జర్మన్ అనేది చాక్లెట్ కి లింక్ అయింది, చాక్లెట్ అనేది 4000 కి లింక్ అయింది. ఆ లింకింగ్ ఈస్ మెయింటైన్డ్ బై సంథింగ్ కాల్డ్ పొజిషనింగ్ ఇండెక్స్. It's all built in by the system. You don't have to worry on that. But by using that positioning indexing, it will be able to link up saying this India is linked up to chocolates and this is linked up to 1000 and what it is. The linking is all taken care by positioning indexing. Okay. Sorry. So you're clear now. If I create a row store table, how does it store in the backend? How does it store my data? You know. If I create that as column store table, how does it store my data in the backend? You know now. Now we have to analyze now, which is better. We'll further discuss and analyze whether my row store is better or column store is better, or in what case row store is better, in what case column store is better. That is what we have to analyze. Okay, boss. Now look at this. My question, okay, this is how it is stored, and I'm trying to run a query like this. Select star from table. Select star from table where my country is US. Select star from table where country is US or where my row number is 4 or something. I'm just trying to read one record.
Hello.
Yeah, hello. Yeah.
Hello.
Hello.
Sir, I'm not able to see your screen. Are you going to write any query?
No, I'm not writing anything. I'm just, it's the same.
You are just explaining, right? Okay.
I'm not writing it.
Okay. Yeah, fine.
Yeah. So the query what we're saying, select star from this table where my country is US or where my row number is 4 or something. Let's say I have some unique number like 1, 2, 3, 4. I'm reading one row. Now tell me which will be faster. To give this result, which type of table would help me, or which type of table would be more suitable for this type of query? Column. Row store is better, right? Because if it is column store, first I need to go to memory location 1. Next I need to jump to different memory location and take the corresponding product. Jump to another memory location, take the corresponding sales and give it to me. Kada? If it is row store, I'll just go to memory location where row number 4 is stored, read all the row value, US, node, I'll just read US, read the noodles, read the value and then give it to you. Column store kottadani cheppi fast kadanna. Ee scenario lo row store fast. Because I'm trying to read complete record of a table, and in case of row store, the entire record is stored at one memory location, so row store would be faster in this case. Okay, boss? So point to be noted. So whenever okay, my analysis is, if you're trying to run a query where you're trying to read the entire row, then row store is faster. Entire record. Yeah. Make a select star from table where country is equal to US. So US, how many records do we have relevant to US? The row number 4 is relevant to US. So there is one memory location where the entire row is sitting here. Look at this. US noodles and this value. So my query will jump to that memory location, read that row values and give it to me. Right? Similarly, if it has to execute the same query in case of column store, it has to first, this is one memory location. It has to jump to first memory location of column 1, pick the country, go to using positioning indexing, get to another memory location, get the column 2, get to another, jump to another memory location, get column 3 values, and then show you the result. So that's what, with this analysis, I'm saying, when you try to read the entire columns of one record of a table, row store is faster. Okay, boss? Now next query, boss. I'm trying to run a query like this. Select countries from a table. Select distinct or whatever. Select countries from table. Now which is faster in this case? Column store. Because if it is row store, I'll have to go to memory location 1, pick first country, jump to second memory location, pick second country, jump to another memory location, pick third country, and jump to another memory location, pick fourth country, and then give me a result. So I'm jumping around 4 memory locations. If it is this case, I'm just going to one memory location where all the countries are stored. I'm just reading only those 4 countries and giving you the result. So which is faster? Column. So can I base it like this? When you're reading certain columns of a table, column store is faster. When you're trying to read particular row of a particular record of a table, then row store is faster. Pretty logical. Yeah. You want to analyze that query. Yeah, we'll have some. You want to analyze the timing and all this. That's what you mean.
Sir, I have a question here.
One second. There's a question going on. In the query. Okay. See, you will just run query and will finally get the result out. That's it. So you're least bothered whether that was structured as a column store in HANA, that was structured as a row store in HANA. But as an HANA modeler, when I want to give out a best performance for the reporting applications, I would configure it in the required format what I want. But when will you raise it to me? Even if I've done some modeling and I've given to you and you're doing reporting and the report performance is really slow and you could do maximum what you could do in the reporting and nothing has improved, then you will raise a ticket to me saying, boss, I'm running this report on this model and there are some performance issues. Can you do something? So if there can be something done at the back end, I will do it. That is it, right? That's how it goes. Okay. Yeah. What is the question for you? Yeah.
Yes, sir. Actually, this is while reading, it will help us like, row store or column store. How are we handling this to, how are we going to analyze while creating the table?
No, no, wait.
Like, based
I'll
on,
come to that. So I'll end up the conclusion. First, let's discuss. I'm analyzing point by point. At the end of this
okay, sir.
topic, I will come into conclusion. In what scenario we have to go for what type of table. Yeah.
Okay, sir. Thank you.
Okay. So now we've come out with 2 points saying if you're reading a complete row of a table, row store. If you're reading certain set of columns, then column store. Now tell me, when you're designing reports for analysis, for analytical purposes, do you tend to read all the columns of a table, or you just drag some columns and try to analyze your data? Generally, whenever you use a table for analytical applications, you use only certain columns of a table, not all. Now tell me, so which table should I use when I'm designing the table for analytical applications? Columns. It is normal when you run your reports, users would just drag and drop certain columns and then try to analyze the report, right? Not all the columns, because only in case of operational reporting, they try to see all the columns. But generally for analytical applications, they try to see only some columns of a table. Then in that case, for analytical applications, I would really say column store would make sense. Okay, boss? Next. So we've analyzed about reading data from a table. Okay, next about writing, inserting a record into table. Let's say I would like to insert a new record into this table, say Nepal, something like say ice cream, and then say 1,000 rupees. Now, when I want to insert data into table, now I would like to analyze whether row store is better or column store is better. I would like to insert a new record saying insert data into this table, values, Nepal, and some ice cream, and then say some sales 1,000. Now, which one is better? Row store. Everyone says row store is better. Why? Because you're inserting new record. It just takes all the values of that record and inserts into the place where memory is all available. If it is column store, it has take one column value Nepal, go to the memory location where country is stored, insert the value there, then go to another memory location, insert ice cream there, then go to another memory location, insert value 1,000. So is it clear? Now whenever I want to insert data into a table, row store is better when compared to column store table. This is conclusion. One point of analyze this now. Right? So you got this point about inserting, right? When it comes to about inserting data into the table, row store looks better. Now, if you look at from outside, row store looks better when compared to column store, right? Yes or no? So what SAP has done is to handle this problem, SAP has built in some mechanism in the back end for column store to handle insert operations also in column store. If you look at generalizedly, row store is better for inserting new record, not the column store. But SAP has done some software innovations, and they built out some logic in the back end of the column store table to handle insert operations, to handle the performance of insert operations. Getting this word? Okay. So that is what we're trying to understand. I'll come to this screen later. That is what we're trying to understand now. So what is the mechanism of the backend mechanism of the column store table, which is enabling me the insert operations also. Good performance on insert operations. That is what we're trying to analyze. Because if I use a column store table for analytical applications, and if it is not giving good performance in writing, there's no point in using column store. Because from the source, I will be extracting and writing records into the table, right? And then I will be doing reporting. If my performance is bad at writing, then what is the point in doing reporting? Ultimately, I decide when I'm using the table for analytical application, I want column store, but at the same time, it should be able to handle even write operations also. So what is the backend mechanism of the column store table, which is handling this mechanism of inserting performance? Clear on this? Okay. I know you get confused. Don't get confused. It's very simple. Take it light. Okay. Now look at this. When you actually create a column store table in HANA, it actually creates two tables. For now, I'm saying two tables, but it's not two tables. It will be two storage locations, you can say. For now, to make it understanding easy, what I'm saying, whenever you create a column store table in HANA, it actually creates two parts or two table parts or two memory locations for the table. One is called as main and one is called as delta. Whenever you create a column store table in SAP HANA, internally it actually configures two parts for it, or it represents a column store table with two tables in it or two storages in it. Two blocks. One is called as main block or main storage and one is called as delta storage. Okay. Now look at this. So on a table, on a given table, you basically do two operations, right? Either writing or reading. Writing is inserting data into the table. Reading is about reading the data for the reporting, right? Now look at this. What I mean to say. So your two storage, one is called as what? Main, and other one is called as what? Delta bus. Every write operation is done on delta, and every read operation will be done on both main and delta bus. Every write operation is performed on the delta storage table, and every read operation will be done from both main as well as delta bus. Okay. Now look at this. Okay, next point here. Now you have delta storage. The delta storage will be more like a row store concept. The delta storage is more like a row store concept, and main store is more like a column storage. Columnar storage. This is more like a row store mechanism with delta. Delta storage or delta block or delta table will be more with the mechanism of row store mechanism, and the main table will be more with the columnar storage mechanism in the backend. Okay, boss? Every write, since my delta storage or delta table is more of optimized for writing with the columnar storage mechanism, my write operations are faster because every write is done on what? Delta. Every write is done on the delta table, and the delta table is optimized for writing. It is more of a row store mechanism, so it is optimized for writing. I can write it very fast. Okay. And when it comes to reading, I'm going to read from main and I'm going to read from what? Delta both of us. Right? Then you say when you're reading from delta, the reading would be slow, right? Yes or no? Yeah. Then when this is going on, as a regular process, you do something called delta merge. You do some process called delta merge. When you execute the process called delta merge, all the data from the main table is moved on to, from delta table to main table asynchronously. User would insert the record, the data gets into delta table. At later point of time, whenever the system is free, you can perform something called delta merge. When the delta merge is executed, it takes the data from delta store and writes it back to main. That is called as delta merge. I'm coming there. See, whenever you design a column store table, it will have two storages in the backend. One is called as main table, delta table. Delta table will be optimized to handle write operations, and main table is more optimized for reading use. Okay, and every time you perform a write operations on a table, it does write data into delta store, and every time you want to read, it does read data from main as well as delta both. Okay. And when you want to move the data from delta to main, we perform something called delta merge. When you execute the process called delta merge, it reads the data from delta and writes the data back to what? Main. So when this is happening, it is asynchronous. Let's say user comes in, he inserts one record, and where is this record getting inserted? Delta. Is it optimized for inserting? So immediately gets a message saying record is inserted. There is no performance issues. He goes back, and when the system is free, you'll execute the delta merge process, which will take data from where? Delta to main asynchronously. User got insert చేసేటప్పుడు నేను మెయిన్ లో పెట్టాను అనుకో, టైం ఎక్కువ బట్టి చాలా సేపు తర్వాత డేటా వాజ్ ఇన్సర్టెడ్ అని వస్తుంది. అలా అవుతుంది ఇప్పుడు లేదు. యూజర్ ఇస్ నాట్, యు ఆర్ నెవర్ ఫీలింగ్ ఇట్ that part now, because every insert is straight away getting into what? Delta, which is more optimized for writing. So writing operation is handled. Okay. That's asynchronously when there is a time gap or when there is time free, you will perform something called delta merge, where you will read data from delta and write into main. That is called delta merge. So SAP is using this internal mechanism to handle even performance of write operations on column store tables. Column store table generally write operations slow ఉంటుంది కాబట్టి వాళ్ళు ఒక మెకానిజం తెచ్చి బ్యాక్ ఎండ్ లో ఈ ఆల్గరిథం పెట్టి ఇన్సర్ట్ ఆపరేషన్స్ కూడా ఫాస్ట్ ఉండేట్టుగా చేస్తున్నాం. సో ఐ హావ్ కాలమ్ స్టోర్ టేబుల్ which can handle insert operations now, which can also handle my analytical applications. So I would go with column store table. Getting this now? Fine.
Okay, sir. In short, when the system is free, the records from Delta will move to the.
No. See, we'll discuss on. See, now you're raising a question saying who will trigger the delta merge? Whether it's more like a compression bus, F table, E table, something like that. Okay, but who will trigger this? Do I trigger this? I'll come to the topic later. But do you understand merging? Next point I'll discuss on who will trigger that.
Actually, sir, I just missed out. It was in the regional language, and I just missed out. I was listening to it.
No, I'm saying, see, when you execute this process called delta merge, it actually reads data from delta and writes it to main. But who is triggering this process of delta merging depends on the next case. There will be different type of merging again. We'll have different types of delta merge. We'll discuss it. And based on the type, who is executing will differ. So how is it executed? It differs. Okay, we'll come to that. Can you repeat again? Because every time you configure a column store table or you create a column store table, internally it creates two storages or two tables or two blocks, you can say. One is main or delta. And delta block is more optimized for write operations, more like a row store concept, optimized for writing. And every read operation is taken care from main as well as delta both. It reads from both the tables. So since my delta is optimized for writing, it is able to handle the performance of write operations. And my reading will be taken care from both main as well as delta. Asynchronously, when the users are not really working on the table, when the table is free or something, we can trigger delta merge, which will basically read data from delta and store into what? Main. Because if I just keep the data in delta what happens? Again, I have the performance of reading performance because it is more like what? Row store. If I just leave the data in the delta table for long, since it is row store optimized, the reading performance will be affected again. So I need to keep pushing the data from delta to main as and when required. Clear is clear now. Now the question is who will do merging? When is this merging getting triggered? And is what we have different types. I'll get into this concept in detail later, but for now just say you'll have different types, like there will be something called auto merge. There will be something called auto merge. So I told you there's a table property called unload priority, preload flag. Same way, while you're creating table, while creating column table, you can say auto merge on and petition. You can enable a table with property where auto merge is enabled. Okay. When you enable the auto merge property on the table, it means auto merge is performed on the table. What does this auto merge mean? Ultimately, any merging, it has to take from delta, put into main. But who is taking care of this? Okay. So for any table, the auto merge is enabled. It will perform auto merge. Auto merge is performed by something called merge dog. In a server, in the HANA server, you'll have a component called merge dog. Okay. And what does this merge dog do? It will be scanning through all the tables in the system. Whenever it finds a table for which auto merge is enabled, it tries to trigger the merging based on a condition being satisfied. In the server configuration, you'll have a component called merge dog. And in the merge dog, you'll have some parameter maintained saying auto merge decision function and a condition where you can write condition saying where my delta store size is 1 GB or where my delta store size is say 30 MB, and you can write some logic there. You can write some formula. So what does merge dog do? It will be scanning through all the tables. Any table for which the delta is satisfying this criteria, it triggers a merging. That is called as auto merge. Clear? While defining a column store table, if you switch on the auto merge, so auto merge is performed automatically by the system. Who is doing it? Merge dog. But when does a merge dog trigger the merging? It will have a decision function maintained. I'll show you in the HANA server configurations. You'll maintain saying auto merge decision function, and you'll have a parameter where you'll specify condition, and you can specify complex condition saying where my delta store should be greater than 30 MB and main store should be so and so, it should have been so and so time. You can write any criteria. So what does merge dog? Merge dog will be always scanning through every table. Whenever it finds any column store table which is satisfying that condition, auto merge decision function condition, it will trigger merging on. That is called auto merge. Okay, now system will issue the token to perform the merging, and merging is done. That is called as auto merge. Clear? Okay. Then you'll have something called forced merge. Then you'll have something called forced merge. So what will you do for this table? Let's say I wanted to handle the merging. I will decide when the merging should be done or when the merging should not be done. What I'll do? I'll switch off that auto merge property. I'll say auto merge off on. So merge dog will never take care about merging this table at all. I should take the responsibility of doing it. So what I'll do? We can write an SQL statement forced merge on this table. We can write an SQL statement, or when you right click on the table, you'll have option called merge delta option. That is like forcefully we are performing the merging on the table. Whenever I want, I can perform the merging on the table. It's a daily once or sounds of timing. I can schedule that with process sharing. If it is BW on HANA, with BW process sharing, I can schedule this merging also. Process sharing to background. Okay, boss. So when you say force merge, it does not check any condition. It will do merging now. Okay, and there will be some other merge, say critical merge. When you say critical merge, you have switched off auto merge. So it was your responsibility to trigger merging, but you forgot to trigger. And delta store reaches to a size where it cannot handle anything more. It reaches to peak state where HANA system can't handle. Then HANA system will trigger the merging. That is called critical merge. Because normal max size of any table is 2 TB, 2 terabyte max. Auto merge was disabled, so system was not taking care about merging, and I never did any merging, so we forgot to do merging on this table, and the size of delta will reach to a size that HANA is not able to handle anymore, and in that case system will trigger merging. That is called as critical merge. So like this, you'll have some different types of merging. We'll see what it is all this, but only point is you understand there's something auto merge which system we can configure system to be triggering merging, or we can also schedule the merging if required. Okay, now which one will you prefer? System gives a mail. Again, I have problems. Generally, since we would prefer the system to do it, but if I assign it to the system, I have some problem. If it is relevant to BW on HANA, we'll have this problem majorly. Okay, see, look at this. So I've got a cube or a DSO. The backend of cube or DSO is what? Column store table. Let's say you're loading by running DTP, you're loading data into those tables. Okay. On top of those tables, let's say you enabled auto merge. Okay. You're loading millions of data at some point of time. At some point of, let's say you loaded some 50% of the data load was completed. At that point of time, it has satisfied the delta merge functionality. It has satisfied auto merge decision function is satisfied. System triggers merging. You're loading millions of data into this DSO table or cube. And after you have finished half of the load, at that point of time, it is satisfied. Let's say the table is satisfied the auto merge decision function. Then what does system do? It will trigger merging. So during the data loading process, the merging is getting triggered, which will affect the loading performance. So what would I prefer? During loading, I don't want the merging to be triggered. So how can I control that if in case of auto merge? It could have triggered any time. We can't say, right? So what I'll do? We'll switch off auto merge, do the finish off your complete data loads, then go over triggering your merging. That is what the focus you should need. So then we'll not go with what? Auto merge. In case of cube or DSO, I'll not go with auto merge. Getting this? Yeah. We'll see that merging out, but you understand what is delta merge now? Yeah. Okay. Stuck in there. PowerPoint stuck here, sorry, no problem. Okay, there's some other point which we want to discuss. Okay, you understood about writing and inserting. Next level is about compression. Like say, I want to store the data of a table, so I can go with row store or column store. Which type of table will consume less space? That's the concept. So about the database sizing is important. We've gone through about reading, we've gone through about writing of data. Now we're trying to understand as part of this aspect of storing more data with less space, which is better, whether row store or column store. So even though it is better for performance of reading or writing, ultimately it should not take a lot of space, right? It should not waste my space. So which type of table would take more space is what we're trying to analyze. Okay, I can draw it here. Okay.
Row store will take more space.
Row store will take more space. Excellent. Row store will take more space. Why and how? Okay, that's okay. Now look at this. So I've got column 1 and I've got column 2. Let's say I've got column 3. Say south, north, east. Okay, I'll have some values like this. Let's say let us assume 2 columns for C1, C2. Let's not worry about C3 also. Let's say I've got 2 columns like this, C1 and C2 with this data. If I go with the row store, so I'll have first memory storing what? South and C1. Next memory is storing north and C2, south and C1, north and every combination is stored. So it ends up storing every row. If I go with column store, now it takes all the values of the column, which one? C1 and store in one memory location. It takes all the values of C2, it stores in one memory location. And while storing, all the duplicates are removed. All the duplicate. So that is one of the compression techniques utilized here. Let's say I've got around 5 to 25, around there are 20 records, 20 values. Okay. So when it comes to what are the distinct values you got, what is the cardinality here? You got only south, north, and what? East. So 20 values will be converted, will be stored, will be with only 3 values: south, north, and east. So am I reducing space? Am I getting a lot of compression with column store? At the row store, it has to know which values for which row. It ends up storing 20 values. It stores the same region 20 times, same or different. It stores 20 cells. Okay. But in case of column store, it just store only distinct values of that column. Okay. All the values of this column are stored in one memory location, and if there are any duplicate, those will be removed. They store only distinct. So am I getting benefit of compression here? So the size required to store the data is less in case of column store when compared to row store. Row store lo ade data store chesi ekku space kavalla, ade columnar storage lo నాకు తక్కువ స్పేస్ లో పెట్టుకోవచ్చు డేటా. అసలు ఆ పాయింట్ చాలా పవర్ఫుల్. ఇమాజిన్ I've got 10 million records and I've got a column called region, like say south, north, east and west are the 4 possible values. Imagine if I go with row store, ఈ values పెట్టక నేను 10 million cells వాడతాను. If I store that in a columnar storage, I just use only what? 4 cells to store that. Isn't the difference? Right? So you can see that effect when you have column store table. When you keep inserting same data multiple times, you'll see there's no data memory size increase. That is what they're using, that kind of compression techniques with column store table. So one second. What SAP says is, when you, let's say you got data stored in another database like say DB2, when you're trying to bring that data into HANA, they say minimum it gets compressed by 4 times, 1/4 of it. And if it is taking 100 GB of space in DB2, which is normal row store technique, when I bring that to column store, at least it gets into 20, it gets reduced to 25 GB. At least 1/4, and it will be reduced by 1/4 of it. That's what concept. So that is all mainly done because of the columnar storage, which is reducing the, because of this compression technique, it is reducing the size required to store the table. You understand this? Okay. One more. I'll just finish one more. One more point. So you understood how each column is being stored. Now next point, since we're getting to store data like this, now each column itself will act like a primary key of my table. Generally, if you look at primary key index, what will happen? You will have unique values, and for each unique value, you know which record you're referring to. Same way, now what is happening? Since I'm just storing only distinct values for each column, and then you'll have something called positioning indexing, which tells you which value is referred to which row, that acts like a primary key. Getting another benefit, since it is just storing only the distinct values, it is as good like storing like index. You're representing the column values as an index in the backend. So look, you would have good performance when you're reading the values. When you say read list of countries where my country is not equal to US, the performance. First thing is you're able to reduce the space required to store data. At the same time, since it is storing only unique values, is it like an index bus? Each column of a column store itself will act like an index bus. Primary column performance. Do you see any difference if it is a normal row store table? When you write a select with where clause on the primary key, performance is better. When you write a select statement with the non-primary key column, the performance will be different. Do you see difference in the performance? Normally, if you take bsec table, if you try to run a select statement without key fields in the where clause, look at the performance with key fields in the where clause. What is the performance? Do you see a lot of difference because of the huge table? So if it is columnar storage, either you have where clause on any column, it can handle, because each column itself is representing like not index, like index. There's a lot of difference. Index undam where, like index undam. It is like index, not index. Okay, boss. So now knowing all these facts, now tell me, do you go with column store or row store? Column store. Because of the backend algorithm, it is able to handle even the write operations. It is good in performance in reading. So it acts like an index, and the space required to store the data is also less. So in all the cases, I would prefer with row store. But only one case where I would prefer, in all cases I would prefer column store. The only one case the row store would be better is when you try to read select star. Anduke, that's what they are saying. In HANA, please do not write select star. It's not a good practice to write select star. So it's like you got to write, even though it is 100 columns, you are trying to read 90, say select column 1, column 2, and 90 పేర్లు పెట్టాల్సింది. రాసేదే కదన్నా, ఒకసారి కదా రాసేది. సిస్టమ్ బాగుంటుంది, మనకు బాగుంటారు పర్లేదు, సిస్టమ్ బాగుంటుంది. Okay, boss. Select star,
sorry to disturb you guys.
Fine, okay. Yeah, tell me, yeah.
Hello?
Yeah.
So you mean to say before compression, the main table and the main content will be duplicated, you mean to say, right? Apart from the C3 example.
See, there's no concept like compression. When it is stored, depth, every column will have delta main. Whatever we're
yes.
speaking about main and delta, every column will have delta store, main store, delta store, main store, allowed.
Yes.
Internal, okay. Let's not worry. See, compress is different. Compress, what I'm saying, it is inbuilt feature in HANA server saying whenever it is storing the values of a column, it will not store duplicate values. It will compress those values and store unique values. And concept of moving data from delta to main is different again. Yeah.
Yes, yes.
Okay.
No, I'm just relating to DS. I got confused.
Okay. Okay. I think it should be clear now, right? So, and there are other options we'll see tomorrow. We'll stop it here. So this is about column store and row store. So ultimately, majority of the cases when you're developing application tables, you go with what? Column store table. Yeah.
Okay, sir, could you please tell how the table will be read when we compress the table? That is when we remove the duplicate records?
First thing is there's no concept of compressing a table. By default,
Okay.
when you store the data as a column store table, the data is compressed by default. No concept like you have to right click on the table and say compress. By default, the tables are compressed.
Okay. Then how is the system going to identify? I mean, as you earlier discussed about how the table will be read in the row store and in the column store.
I'm not able to open that PowerPoint. I'm not able to type in. That's a problem. Shall I show you?
Okay, no problem.
The system is stuck. There is a slide which you will see. I'll show you that screen. How does it link that? There will be something called positioning indexing and other indexes. I'll show you tomorrow on that screen.
Okay, no problem.
But actually, the thing is that it does store only unique values. So it does occupy less space, and each column itself will act like an index. So I'll tell you, she's asking if I'm trying to read only for US region, so how does it know for US region what all rows do we have? How does it link? So actually, again, it does. There's next concept for in compression concepts, you'll have some dictionary based integer coding. So for each value, it does assign one integer. Based on the numbers, it maintains some index, and from the numbers, it will have positioning index. I'll tell you that tomorrow. Okay. Okay, we start. Thank you.